Have you ever wondered if the Earth could be shaped like a donut? Now, before you dismiss it as absurd, let's delve into the fascinating concept of a toroidal planet. The term toroidal refers to anything shaped like a ring or a donut, and it's not as alien a concept as you might think. It invites us to challenge our preconceived notions about the shape of the Earth. Imagine for a moment living on a donut-shaped Earth. What would that look like? To understand if the Earth could be donut-shaped, we must first understand why most planets are spherical. The answer to this lies in the fundamental force that governs our universe: gravity. Imagine a clump of matter floating in space. Now, gravity is an attractive force, meaning it pulls things together. It acts from the center of mass, pulling each piece of matter towards every other piece. This creates a force that pulls everything inwards, towards the center. As this happens, our clump of matter begins to compress and compact, forming a shape that minimizes the distance from the center to any point on the surface. This shape, as it turns out, is a sphere. That's why when you look out into the cosmos, you'll see that most celestial bodies, from stars to gas giants, are spherical. But what about the exceptions? What about bodies that aren't quite perfect spheres? This brings us to the concept of hydrostatic equilibrium. This is the balance of forces that gives celestial bodies their round shape. In simple terms, hydrostatic equilibrium is a state in which the pressure from the weight of material pressing downwards is balanced by the pressure from the heat and light pushing outwards. This balance ensures that the celestial body maintains its round shape. However, not all celestial bodies are in hydrostatic equilibrium. Some bodies, like certain asteroids and comets, aren't massive enough for their gravity to pull them into a round shape. Others, like rapidly spinning neutron stars, are distorted into oblate spheroids due to their high rotation speeds. So, with gravity pulling everything into a spherical shape, how could a planet possibly be donut-shaped? Scientists have theorized that under very specific conditions, a planet could form into a torus or donut shape. But what are these conditions, and how could they possibly lead to a celestial body with a hole in the middle? Let's delve deeper into this fascinating theory. Imagine a spinning disk of dust and gas, the early stages of a planet forming. Now, if this spinning disk had just the right amount of angular momentum, it could start to bulge at the equator. This bulging would be due to the centrifugal force caused by the rotation. Centrifugal force, as many of you might recall, is the apparent force that draws a rotating body away from the center of rotation. It's what makes you lean to one side when you're spinning around in a circle. Now, if this force is strong enough in our disk of dust and gas, it could cause the material to spread out and form a sort of ring. However, for this ring to become a torus, the gravitational pull inward would have to be perfectly balanced with the centrifugal force pushing outward. This would mean that the mass of the disk would have to be distributed in such a way that the gravitational forces holding everything together are in perfect harmony with the forces trying to fling everything apart. It's a bit like spinning a pizza dough. Spin it too slowly, and it stays a blob. Spin it too fast, and it flies apart. But spin it just right, and you get a nice, flat circle. Except in the case of our planet, we're aiming for a donut, not a pizza. This delicate balance is a tough one to strike. It's like trying to balance a pencil on its point. Even the slightest disturbance could topple the whole thing. That's why the formation of a toroidal planet is highly unlikely. But remember, in the vast and diverse universe we live in, highly unlikely is not the same as impossible. So while you shouldn't expect to find a donut-shaped planet in our next space mission, you can't rule it out completely. This delicate balance makes the formation of a toroidal planet highly unlikely but not impossible. So, what would life be like on a donut-shaped Earth? Well, let's dive into the realm of the speculative and imagine the implications of living on a toroidal planet. It's a world where the mundane and the extraordinary would coexist in ways we can hardly fathom. Firstly, the climate variations would be extreme. A planet's climate is largely determined by its shape and rotation. So on a donut-shaped planet, the inner and outer regions would receive different amounts of sunlight. This could result in one side having a tropical climate, while the other experiences perpetual winter. The difference in sunlight would also lead to unusual weather patterns, potentially causing intense windstorms as air moves from the hotter to the colder regions. Next, consider the day-night cycles. On our spherical Earth, we experience roughly equal periods of day and night. But on a toroidal planet, things would be different. Depending on where you are, you might see the sun rise and set multiple times a day, or perhaps not at all. Now let's talk gravity. Gravity on a toroidal planet would be distorted and uneven. In the center of the donut, gravity would pull you towards the sides, potentially making you feel lighter. As you move towards the outer edge, you'd feel heavier. This would have profound impacts on the development of life and the evolution of species. We might see creatures adapted to varying gravity levels, with stronger, more robust forms on the outer edges and lighter, more agile creatures in the center. And then there's the issue of navigation. With a hole in the middle and a twisted surface, finding your way around a toroidal Earth would be quite a challenge. Traditional compasses would be useless, and GPS systems would need a complete overhaul. In short, life on a toroidal Earth would be a cocktail of the fascinating and the bizarre, a blend of the familiar and the alien. It's a world where the rules we take for granted are rewritten, and the ordinary becomes extraordinary. Life on a toroidal Earth would certainly be a unique experience. But is our Earth actually donut-shaped? A captivating question indeed. Yet the evidence we've gathered over centuries of exploration and scientific advancement suggests otherwise. Let's start with the satellite images. Thanks to the advancements in space technology, we've been able to send numerous satellites into space that have given us a bird's-eye view of our planet. These images, consistently and without exception, showcase our Earth as a beautiful, glowing sphere. Not a single hint of a hole in the middle or a toroidal shape to be found. Moving on, let's consider Earth's shadow on the moon during a lunar eclipse. This natural phenomenon has given us a simple yet convincing proof of Earth's shape. As our planet moves between the sun and the moon, it casts a shadow on the moon's surface. This shadow is always round, a clear indication of a spherical object. If Earth were donut-shaped, the shadow would take on an oval or even a circular ring shape, which we have never observed. Finally, we have the phenomenon of ships disappearing over the horizon. This is a sight most of us are familiar with. As a ship sails away from the shore, it appears to gradually sink below the horizon. First, the hull disappears, followed by the middle of the ship, and finally, the top of the mast. This occurrence can be explained by the curvature of a spherical Earth. If our planet was shaped like a donut, the ship would simply get smaller and smaller, but it would never disappear from sight. In conclusion, the evidence in support of a spherical Earth is extensive and compelling. Satellite images, the shape of Earth's shadow during a lunar eclipse, and the phenomenon of ships disappearing over the horizon all point to a globe, not a donut. While the concept of a donut-shaped Earth is fascinating, the evidence overwhelmingly supports a spherical Earth. Today, we've taken a journey from the realm of spherical planets, through the theoretical possibility of a toroidal Earth, to the reality of our round home. We delved into the forces that mold planets into their familiar forms, the interplay of gravity and rotation that crafts celestial bodies into spheres. Our imaginations then took us to the realm of toroidal planets, a concept that, while not observed in nature, provides a fascinating thought experiment. We explored how gravity would behave differently on a donut-shaped world, leading to unique phenomena and potentially exotic life forms. We also considered what life would be like on such a planet. With varying gravitational forces and climate zones, a torus could host a kaleidoscope of environments, each with its own challenges and opportunities for life as we know it. But, as exciting as these possibilities may be, we must also face the reality of our Earth. Our home is not a donut, but a sphere. The evidence is overwhelming, from the images of our planet taken from space, to the way our planet's gravity behaves, to the predictable patterns of the stars in our night sky. While the Earth may not be donut-shaped, exploring these possibilities expands our understanding of the universe and the forces that shape it. So, let's keep pondering, questioning, and exploring, because the universe is full of wonders waiting to be discovered.